Good afternoon, everyone. Today we will be talking about our project, which we have uh, performed. So, our topic for the project is predicting real-time traffic accidents in the US, which has been performed by our group members, as you can see the name below. Moving on to the contents, first we will be talking about moving on to the contents of this presentation. First up is the introduction, in which we will be talking about the background, the motivation for doing this topic, then a research problem, and following with that, the research questions. And moving on to the methods, we will be talking about the uh, methods or tools which we used for visualizations and data analysis. Uh, and based on that, we'll be reporting our results in terms of visualization, optimizing models and predictions, and then we're going to discuss about the insights on the findings, provide recommendations, innovation, contribution, feasibility reports, and finally we will be concluding our project, uh, talking about the key findings and the key takeaways. Moving on to introduction, in terms of the motivation, or in terms of the motivation, our motivation was to protect the residents of the US from getting into accidents. Our purpose is to predict how often accidents occur and what are the factors that lead to it. As people residing in the country, we want to serve the nation and make it easier for others so they can minimize the risk of accidents. Moving on to our problem statement or research problem, as mentioned before, our problem statement is, can we predict real-time accidents in the US through factors affecting accident severity? And in terms of importance, the project is highly important because there is an alarming number of accidents occurring in the US every year, which is becoming dangerous for the lives of the people. We want to identify the locations where accidents happen the most so we can warn both people and the police department, so that they can add extra uh, security and safety for the citizens of the country. And in terms of the research questions, based on the research problem, we have come up with a couple of research questions which will help us analyze our uh, help us analyze and come to the solution of our research problem. Those questions are: number one, what are the factors that affect accident severity? Number two, what is the prime time for accidents to occur? Number three, which state has the most number of accidents? Number four, what is the impact of precipitation or other environment stimuli? Number five, which location is the hotspot for accidents?
As for the method, we use Tableau for the visualization and Python for modeling and the prediction. As for the variable description, here is our variables: severity, latitude, longitude, distance in miles, size, temperature, humidity, pressure, visibility, wind speed, weather condition, and the places of the traffic accident like junction, railway, station, stop, and traffic signals, and so on. As for the missing value inputting, we drop columns where almost half observation are missing values, and we fill the rest missing values by using the mean values. As for the data cleaning and preparing, we will talk more about it later in the modeling part. And then next, we will talk about the visualization. This map shows that the frequency of accidents according to state boundaries in the United States. The depth of the color represents the frequency. The dark red part represents accident-prone states like California, which has over 160,000 accidents from February 2016 to December 2019, followed by Texas and Florida, with almost 300,000 accidents in each of the two states. South and North Dakota have very few accidents, average less than 20 per year. From the bubble map, we can see that California ranked first, followed by Texas, Florida, North Carolina, and New York at 2, 3, 4, and 5 respectively. At the other end of the list, there are states with a lower frequency. And then, this map shows the density of the occurring distribution, which is on the right side, with each point representing the longitude and latitude of the recorded accident location. In this picture, we didn't set the color change. The dark gray area represents too many overlays that cause the color to deepen. So we can see that the West Coast and the East Coast are accident-prone areas. Compared to the security map, which is on the left side, we were surprised to find that although the frequency of accident in the central region was very low, the severity of the accidents in the central region was much greater than that on the West and East Coasts. We believe this because in California, almost every family member owns a car. The main means of transportation is by car, so the frequency of accident is naturally high. On the other hand, Massachusetts and New York have very large population and thus are accident-prone area too. In contrast, the central regions, which has a smaller population distributions per square mile, has fewer traffic accidents. However, since there are fewer cars on the road, drivers may drive at high speed, and thus accidents can be really dangerous. Then, these three charts compare the frequency of accidents over 24 hours. The gray chart shows the number of accidents that occurred at the same time during the whole week. The purple chart shows the number of accidents occurring at the same time during weekdays. The orange chart shows the number of accidents over the weekend. During weekdays, the accident peak at 7 to 9 a.m. and 4 to 6 p.m., which is rush hour. On weekends, it is concentrated at 11 or 12 to 3 p.m. Then, this chart shows that the traffic accident rate is concentrated on weekdays. And this light chart shows the frequency of accidents in each month of the year. The frequency of accidents in the first half of the year was around 200,000, rising from June and peaking in October, and then falling again, maybe due to the weather conditions. Then, this chart shows the amount of accidents at different visibility, temperatures, and wind speed. In the beginning, we can see that visibility is about 10 miles, during which accident can be the highest. According to a temperature table, the accident rate was between 60 degrees and 90 degrees, mainly in the warm weather. As can be seen from the wind speed chart, the number of accidents varies from 2 to 20 mph, but it is mostly between 5 and 10 mph. Then, these two charts show the proportion of the major weather conditions. We set the limit to more than 1,000 accidents. Unexpectedly, we found that most accidents happen in clear weather. Other accidents are more likely to happen in light rain than in heavy rain. Apparently, the next most accident-prone weather was overcast and most cloudy, with poor visibility. Then, this is a comparison of the number of accidents in fog, light rain, snow, versus the severity which we did using Python. We can see that light rain has more accidents, followed by rain and fog. More than 41% of accidents were above severity 3. in snow weather. Rain weather with a severity of 3 accounted for more than 45%. Thus, there is a high probability of a serious accident. The scatter map shows whether the accident occurred on those major traffic points. We can look at the number of choose parts here. It can be seen that most accidents are caused at traffic signals. The button on this picture here is a true button. You can see that obviously is at the traffic signal. Then, from this chart, there were over 400,000 accidents at traffic signals, followed by crossing over 175,000, and junctions about 130,000. Accidents at junction are usually serious, with 43% or more being accidents with a severity 3. Secondly, more than 20% of the severity 3 accidents were on the railway tracks.
Hi, let's move on. This part is about modeling. Here, we used Python and set accident severity as the dependent variable. Severity has 4 classes, which scaled from 1 to 4. First, we did data preparation. We dropped several columns which are not fit for modeling, like accident description, or columns that has too many missing values, like precipitation, where almost half of the observations are missing. Then we check the correlations among predictors. We can see that there's no severe correlations between predictors, which is great. And for modeling, we choose 3 algorithms, which are logistic regression, random forest, and gradient boosting. And their accuracy are 16%, 91%, and 72% correspondingly. So it's obvious that the random forest performed the best. So we did hyperparameter tuning on it by grid search and found that we already got the best params, and its best score is 91%. Here is the feature importance plot from random forest, and the top 3 are distance, temperature, and pressure. Except distance, which is the length of the road extent affected by the accident and apparently related to the severity. Other items, top items related to weather, like temperature, pressure, humidity, are to be the crucial features in model. And second, the latitude and longitude seems also to have influence on accident severity.
Then as for the insights on findings, we can see this word cloud. The keyword is that exit. We can see big 3 exits here. As we mentioned before, the most prone place is at the traffic signals. And here we can conclude that exit is also the most place. Then, for the recommendations, for drivers should drive carefully even on sunny days, and use alternate means of transportation or stay indoors during inclement weather. For pedestrians, take extra care at intersections and at the exit of the all lanes, which are blind spots for drivers. During rush hour, leave a little early so you don't have to be in a hurry. And in the holiday travel, you can have the one more driver so you can avoid fatigue driving.
All right, moving on to the conclusion. Uh, through our uh, analysis and visualization, we have identified that California has the most number of accidents in terms of the state in the US. Uh, In terms of weather, it is mostly between 60 to 90 with wind speed of 5 and 10 miles per hour is when the accident is more likely to occur. And the most favorable weather conditions for accidents to occur is the clear weather, uh, following with uh, overcast and mostly cloudy with light rain. In terms of accident severity, 41% were above severity 3 on a scale of 1 to 4 severity, with 1 being low, 4 being high. 41% were above severity 3 in snow and 45% in rain. The accident peak timings, uh, on weekdays, it was 7 to 9 a.m. in the morning and 4 to 6 p.m. in the evening. And on weekends, it was 12 to 3 p.m. October was identified as the peak month of most likely accidents to occur. And in terms of location, the traffic signals reported the most number of accidents in the US. Thank you.